Hello everybody. In this presentation, I'm going to try to outline the challenges that we face in using images and video as a means to assess biodiversity in the deep sea. I'm going to do that by way of this diagram, which shows the pathway of image-based data from collection of the raw data through to storage of the eventual biodiversity records. The diagram you can see on this slide here comes from a JNCC report from the Big Picture Working Group. And it was developed by Van Rijn, Smith, Postlethwaite and Lear, and I've adapted it slightly for the international perspective that we have in this meeting. So just thinking about the pathway that image data go through, there's step 1, where we initially collect the data. Step 2 is in the storage of that data coming back from cruises and campaigns, and the onward use of any of that data for other purposes, such as education and outreach. Step 3 then really is in the quality control and cleaning of that data set ready for analysis. Step 4 is then the analysis of that image-based data for the purposes of extracting biodiversity information. And then step 5 is the storage of the annotation records, both the biological and abiotic data associated with those records. Step 6, if we get onto that, is thinking about reporting. So this collectively shows that flow of the image-based data from start to finish. And each one of these steps is associated with a challenge or a set of challenges that we will be considering throughout the course of this workshop. So let's begin with step 1, which will be the first agenda item in this meeting. And that's at the image acquisition stage. We're all familiar with the process of going out on a research cruise or campaign to undertake some level of biological survey of the deep sea environment. And in that process, we collect data, both imagery, stills imagery, video, and also then associated metadata from various bits of kit. And this presents one of the first challenges, is that in the acquisition of these data, we are using a range of different gear types. And that might range from something like a drop camera system or a towed camera system, so relatively cheap and straightforward systems, through to things like ROVs and increasingly AUVs. And these different gear types produce different fields of view. So you can see here the fields of view, for example, from a drop camera system, from an ROV system, and from an AUV system. AUV cameras tend to look downwards, ROVs tend to look forwards and downwards, so and obliquely forwards. Drop camera systems also tend to look downwards. And those fields of view are quite variable, and therefore the range of organisms you can see is also variable. In addition, the height off bottom that these equipment are deployed can then change dramatically the field of view and also the level of lighting that you have. So what you can see here is actually an image from a drop camera of the same bit of sea floor, from the equipment being on the sea floor to 1 meter off bottom to 2 meters off bottom, and you can see how it changes what you can actually see in your field of view. There'll also be differences in the resolution of the imagery. So in image in the top left-hand corner, you can see image A and B. This is an interlaced versus a deinterlaced image of the same thing. There is a little bit of blurring in A, so it's not quite accurate. It may be your lighting conditions are different. You can easily overexpose your images and produce something that is far too whited out, as it were, to really see properly what's in the image. And it may be there are different conditions on the day of your surveys. I mean, even that can affect the quality of the imagery that you can obtain. So here in this picture in the bottom right-hand corner, you can see it's an extremely snowy day, and that will alter what you can actually see in your image. So there are lots of things to consider in the acquisition of data that may cause challenges in what is obtained, the quality of what is obtained. So moving on to step 2 now, having acquired some imagery data or image-based data, and I include video within that, then there's an issue of storage of that data and making it available to others. And I think it's safe to say almost no one does this well in terms of how these video and image-based data sets are archived. Even within research institutions, things are not done particularly well. So the sorts of things we might need to consider are, do we need local versus centralized storage of these kinds of data when thinking about the international context? Are these data findable, accessible, interoperable, and reusable, or FAIR as it's known? And this is a really important point. These data are extremely valuable. And they have value beyond just the immediate use of analysis for assessment purposes. Image data are very valuable as training materials. They're very valuable for outreach and media and education. And so we need to think about those onward uses and those repeated uses. Things that we may want to consider are common archive formats. I'm not sure people have common archive formats even within institutions for how different cruises are archived and kept safe for future use. Things like common folder structures might be useful. Common metadata standards. So even simple things like using time with a capital T as opposed to time with a small t as your column headings in your metadata files. These sorts of things we have no standards for at the moment. And this makes it really difficult to then automate processes of data archiving. Our data are not currently machine readable, I would argue. And then there's questions around, do we need to archive everything or just cleaned raw data? And what I mean by that is we all collect lots of imagery, and there will always be a good proportion of that that's not usable. It may be that it's overexposed, or it may be there are silk clouds that obscure your vision of what's in the image. Do we want to archive all of these things, or do we really just want to archive an analysis-ready data set? These are things we should consider. And then we've mentioned that onward use, and do we maybe need tags to facilitate wider use of our data? So let's move on to step 3 and 4 together, really, which is, for me, one of the largest challenges we face in terms of making best use of image and video data, and particularly improving the quality of video and image-based data. So the great challenge here really is in the analysis of images and video and trying to standardize the analysis of images and video such that data sets are comparable, observer bias is minimized, and we are able to combine data sets to say something wider about a region of study. I think it's fair to say at the moment it is general practice for individuals who are annotating or interpreting image or video data to generate a reference library, an image reference library of the different taxa that have been viewed during that analysis process. And these reference libraries are created by individuals doing the interpretation. Some institutions have in-house libraries that everybody uses, but there is no common reference library at the moment. I mean, this is particularly a problem when dealing with morphotaxa. So there are some groups for which identification to any reasonable taxonomic level in the field is very challenging. And so we tend to use morphological taxa as a means of grouping things into recognizable and distinct categories. But there are no standards around those categories at the moment, and this is a problem. We've also got a problem with our tools. So traditional taxonomic keys are built on the basis of dead animals in jars, and often things that you can see under a microscope from a preserved specimen. Taxonomic keys are not built for field use, and so we lack the tools that we need to help raise standards in the analysis of imagery and video. It would be lovely to have the equivalent to this very common book in the UK at least, which is the Hamlin Guide to the Seashore. It's a pictorial guide to the common animals that live on the seashore to aid with field identification of animals. And actually some of these do exist for the deep sea. We have the Northeast Atlantic Deep Sea Guide produced by ourselves at Plymouth and Ifremer. There's the Okeanos Animal Guide. There's the Howell Guide over in Hawaii. And there's also the Deep Sea ID app, which we'll hear about. But these are just visual catalogues of animals. What we desperately need are keys, field keys, to identify deep sea organisms, to help train people and standardize what we do. Even in the annotation process, in the interpretation of imagery, we are using different softwares. This is an extract from the VARS software from Mbari, where observations of animals in imagery, in video, are time-stamped. So there's a stamp made at the time when an animal is seen. And this is different to the type of annotation that we do in something like Beagle, and we'll hear more about this during the course of this meeting, where the animals are actually put in a box or in a circle in this case, and physically annotated in the image. So we're not even standardized in terms of the images, the way we are interpreting images. And on top of this, what we really need are some QA and QC procedures, so quality control procedures. If we want to produce data sets of good quality, we need to start thinking about how we can independently assess and quality control different observers' data coming in, and check that the identifications are correct and that we're all on the same page with how we're identifying things. And this then leads on to the need for training, and that this can be part of a training process to ensure that observers have some standards and some level of standardization between observers to produce decent data. So moving on then to the storage of these data. So having collected data, having archived the raw or vaguely cleaned data coming off vessels, having annotated those data and associated metadata, we need to think about how to permanently archive these data such that we can return to them to query any of it if we have any questions about it, and that these data can then serve other onward processes, such as helping to train other people, so other humans. So pre-analyzed data, pre-annotated data is a really great way of training new people coming into this area in how to identify taxa. But these data that are pre-annotated are also extremely useful in training machines, and we'll hear more about that during the course of the meeting. So data that are annotated, at the very least, will have associated metadata with them. So observations of taxa made from imagery may have associated latitude and longitude data, depth data, dates, cruise information, environmental data associated with that. And we need to think about how to preserve that metadata alongside the annotations made. The actual image annotated or the video annotated itself, there will be an annotation file. There'll be the image name or the video name. It might be a timestamp or a frame number that's important in the annotation. It may also include XY position of an animal in the physical image, and that may also include the coordinates of a bounding shape. It could be a circle, as in the case shown here, or it could be a box. But these data are extraordinarily valuable, and so we need to find ways of appropriately archiving this information. At present, there is almost nowhere to archive these data. Okay, and then considering really the final step then, which is in the archiving of the biodiversity records themselves that come from the analysis of the image data. And that may be as simple as putting the data into OBIS, and that might be entirely doable. But there may be some important considerations to be made in the archiving of image-based data. For example, I return to this issue of morphotaxa. Among the sponges, we frequently cannot identify them to species level, genera level, or anything approaching decent taxonomy. But we may group them according to their growth forms or their morphology. So we have branching forms, cup forms, tube-based forms, encrusting forms, etc. You can see the diversity of forms we have of sponges. Is OBIS capable of taking morphotaxa data and preserving that information with reference to a standard reference library? I don't know, it might be. But these things need consideration. There may be special considerations for image-based and video-based data that OBIS may not quite be set up for. It will be interesting to find out in this meeting. And so what I hope we can achieve then over the course of this workshop is to think about each of these steps in turn as different agenda items through our workshop, and consider for each of these steps the different challenges that we face. I've tried to outline some of them here. I've no doubt I've missed some, but we need to think about each of the challenges and think about potential ways forward and hear about potential innovations that have already happened that may act as a solution to some of these challenges. Because for image and video data to really come of age, we must try to solve these problems and improve both the quality of the data coming from image and video-based analysis, and also the accessibility of those data to others for reanalysis or legitimate other purposes. So I thank you very much for listening, and I look forward to some very fruitful discussions over the next 2 days. Thank you very much.